Assalamualaikum warahmatullahi wabarakatuh and greetings. So here is our House of Quality and Innovation map.
Let's begin by looking at what our customers' preferences are in a sunscreen. First, high UV protection is the most important preference. Customer wants confidence that their skin is shielded from harmful rays, especially in tropical climates like ours. Second, they expect the product to spread easily when applied. A smooth, effortless application enhances user experience and encourages regular use. Third, the sunscreen should resist flowing under gravity. In other words, it shouldn't drip or run, especially in humid conditions. This ensures better coverage and less mess. Fourth, a skin-friendly formula is very important. Customers are increasingly aware of ingredients and want products that are gentle, non-irritating, and suitable for sensitive skins. Finally, a pleasant fragrance plays a subtle but powerful role. A fresh scent can elevate the product from functional to enjoyable, reinforcing the brand's loyalty.
For the technical parameter, there are five main parameters where the first one is the UV filter type and the concentration, where this is the most important component in the sunscreen because it determines how well the product can block harmful UV radiation. So the concentration is adjusted to achieve the desired SPF level, for example SPF 50 and the SPF 30. The next one is the fragrance type and the concentration, where the fragrance improve the sensory appeal of the sunscreen, making it more pleasant to use. However, it must be used in the low concentration, usually below 1% to prevent the skin irritation, especially for the sensitive skin. So non-allergenic or natural fragrance are often preferred. The third one is the emulsion type, where the most sunscreen are all in water emulsions because they feel lighter and less greasy on the skin. However, the water in all emulsion can be used for better water resistance, especially for outdoor or sports sunscreen. The fourth one is the emollient type and the concentration, where it can help to soften and smooth the skin while improving the spreadability of the product. The last one is the film forming agent, where this component will help the sunscreen to form a thin, uniform layer on the skin, which enhance the water resistance and keep the UV filter evenly distributed.
Next, I would like to introduce the interaction matrix, which is appear on top of the house. So interaction matrix basically summarize the synergies and conflicts among technical requirements of the product, which is sunscreen for our group. So there are two signs to indicate their relationship. So there are plus and minus sign. A plus sign indicates a beneficial, positive, or mutually assisting interaction or impact, while minus sign indicates a detrimental, negative, or conflicting interaction or impact, while nothing means no effect. So, in the HOQ diagram, the UV filter type and concentration and emulsion type has a positive and mutually assisting impact since they are affecting each other, and the emulsion type is depending on the UV type and concentration. While for the film forming agent and the UV type and concentration, they indicates a plus sign also, since film forming agent depends on the UV type and concentration.
I'm Joshua, and next I'll be explaining the waving factor used in our house of quality analysis. We have identified five key customer requirements and rated their importance from 1 to 5, with 5 being the most critical. High UV protection and skin friendly formula both receive 5 because the consumer would prioritize strong protection and also safety for sensitive skin. Spread easily was rated 4 since the texture would affect the daily usability, while stable texture was given 3 for moderate influence on product consistency. Finally, present fragrance is rated 2 as it is contribute to comfort but is not a major performance factor. These importance rating are later multiplied by each product score to determine the overall performance ranking.
Next is importance rating, where it display at the bottom of HOQ. It's identify which technical parameter most strongly contribute to fulfilling those customer preference. It is calculated by multiplying the customer importance from the weighting factor with the relationship strength in the metric. So the relationship is 1 equal to weak, 3 equal to medium, and 9 equal to strong for each technical parameter. So the results show that UV filter type and concentration achieve the highest score, which is 110, indicating it is the most critical factor affecting UV protection and skin safety. Emollients type and concentration given a total of 19.8, and film forming agent have result to a 91 also rank highly, as they strongly influence spreadability, film stability, and overall comfort. So emulsion type, which given 64 in total, had a moderate impact, while fragrance type and concentration, or given 28 in the total, show the lowest contribution, since it mainly affects sensory experience rather than product performance. So overall, this result demonstrate that the formulation priorities for La Roche-Posay and Tilios should focus on optimizing UV filter composition, emollient balance, and film forming stability, as these have the greatest effect on meeting consumer expectations for protection, comfort, and safety.
Next is the competitive metrics. Each product was rated 2 to 5 for how well it meets every customer's requirement. The Roche-Posay scored highest in UV protection and skin friendliness due to its dermatologist-tested formulation and strong UVA and UVB filters. Supergoop Unseen ranked second, performing best in spreadability and fragrance thanks to its smooth primer-like texture. Neutrogena Ultra Sheer show good texture stability but lower comfort for sensitive skin, while CeraVe Hydrating Mineral, though gentle, score lowest because of its thick texture and visible residue. After applying the waving factor, La Roche-Posay achieved the highest total score, confirming it best aligned with the key customer expectations.
Let's walk through the process technology behind Maxine synthesis. We begin with solid-state reaction, where metal, aluminium, and carbon precursors are heated to form a layered max phase. This step is important as it defines the structural integrity and composition of the final maxine. Next, we move to etching, where the A layer, typically aluminium, is selectively removed using chemical agents like hydrofluoric acid, or safer alternatives like lithium fluoride or hydrochloric acid. This transforms the max phase into a 2D maxine structures with exposed transition metal layers.
Next, I'll be presenting the material maxine. First is the titanium aluminum carbide, which is a max phase material. It has a layered structure of titanium, aluminum, and carbon. It combines the metallic conductivity with ceramic strength, which is the starting point for maxine. Next is layer maxine, which we get by removing the aluminum. It is a thin 2D sheet with high surface area, excellent conductivity, and flexibility. It is perfect for energy storage and sensor. Finally is the functional maxine, which is the maxine with added surface group. This group will improve its chemical reactivity, dispersion, and compatibility, making it ideal for specialized applications like water purification and catalysis.
Next, I would like to introduce the technical differentiation and product. So there are three technical differentiations. The first is special surface termination, which means the functional groups formed from etching process, allowing tunable surface chemistry. So it can lead to the MCIN-based photothermal therapy product, which is cancer treatment page. And the second is the high electrochemical activity, which has large surface area, active metal site, and fast ion transport. So it can produce MCIN halogenated zinc ion battery, which is EV car battery. And the third one is high conductive and optical transparency. Since metallic transition metal layers provide delocalized electrons for charge transport, and ultra-thin layers allow for light transmissions. So it can produce MCIN-based transparent heater film, which is windshield.
For the customer value proposition, the first one is for invasive thermal treatment, where the use of enzyme-based photothermal material provide high precision heating suitable for medical applications such as cancer treatment patch. So this ensure target therapy with minimal damage to surrounding tissue. And the next one is for energy storage. MZin halogenate zinc ion battery deliver fast charging and long cycle life, offering the significant advantage for electric vehicle battery where both charging speed and durability are critical. And the last one is for transparent heater applications such as smart windshield or defogging system. The MZin based heater film ensure fast and efficient heating with excellent electrical conductivity and optical transparency.